What's up guys, today I will demonstrate how to create a friend system. First, let's consider how many APIs are needed for a friend system. We will need one API to list all pending friend requests, another to list all friends, and one more to get the details of a friend. These APIs are called queries because they only retrieving the data without modifying them. Next, we need a web API to send a friend request, one to accept a friend request, one to reject it, and one to delete a friend request. These are known as mutations, which means that they are modifying the data. Additionally, we want to receive notifications when certain event happens, such as when a user receives a friend request, when their request is accepted or rejected, and when the friend request is deleted. These APIs are subscriptions, which notify you when the data changes due to the mutations. With AWS appsync, creating those web APIs is straightforward. We have provided a CloudFormation template for to help you create a same friend system with just one click. First, let's create a GraphQL schema to define all functions, including their inputs and outputs, as well as a data table to store a friend request. To control what the web API does to the database, we use resolvers. At the beginning of each web API call, we verify the caller and retrieve their username from the access token. To list pending friend requests, we link the resolver to a Lambda function that queries the data table using the caller's username. Similarly, we link another Lambda function to list all friends and get their details. When sending a friend request, we first search for a recipient using the username, email, or preferred username. Once we find them, we check their friend status and if they are not already friends or have a pending request, we update the data table to create a friend request. Accepting or rejecting a friend request is simple. We just update or delete a request in the data table depending on the action. The same logic applies to deleting a friend request. We first check the friend status, retrieve the record from the data table, and delete it. Additionally, we need to filter friend requests related to the caller and the friends to ensure the caller only receives notifications for their own friend requests. Now, let's look at how to execute those web APIs. You can generate queries from the APIs using tools like Rapid API or Firecam. Once generated, we can use them to send API requests. For example, list pending friend request query loads the first 20 pending requests, and if there are more, it returns next token for pagination. To load more, you simply send the request again using the token. Refreshing the pending friend list works the same way. While listing friends allow a similar process, to get detailed information about each friend, we use the getUser API, which retrieves their username, avatar, and other attributes. To send a mutation request for a friend request, the process is similar to sending a query request. We gather the necessary parameters for a friend request API and submit the request. To allow the recipient to receive the friend request in real time, we need to subscribe to the friend request sign subscription. To handle this, we first set up a subscription handler to manage income messages. We then connect this handler to the API, specifying what we want to subscribe to. Inside the handler, an event is triggered when the data is received, allowing us to capture the friend request sent by the sender. Sending an accept, reject, or delete request follow a similar approach. To get notification when the recipient accepts, rejects, or delete a friend request, we also need to subscribe to these events. We can subscribe to 3 accept, rejected, and deleted using a single handler. And in event where data is received, we can distinguish between them by their unique IDs. In order to upload our project to the AWS, we will need to compile our project as Linux server executable. We will show you both in Mac and Windows. For Mac, you will need to go to the project folder and type those commands in the terminal, like bash /initiate build linux.sh, and we will just wait till it finished. And in Windows, the step is pretty straightforward and easy. So you just go to the editor and go to Platforms, Linux, ARM64, pick Development and the server and package project. And that's it. Yeah, it's compiled. And very important, once you compile, you package your server, instead of zip the entire server, you will need to compress the content of the server, like showing the video. That's very important. If you not doing that, you will probably get some error, something like cannot find the path to the server file. So basically just follow what the video did, like right here, just compress the content of the folder instead of entire folder. Then just select that zip file. You will need that very soon. So go to the AWS S3, Amazon S3 at the left corner. You just click the create a new bucket and add tags if you wish, but you can just leave it empty. But making sure that you will need to enable the bucket versioning right here, because for every time that you upload your file, if it is the same name, it will just you will need the version ID for updating the CloudFormation stack. So just drag and drop follow as the video. You drop right there and wait. Select the file and click upload. And we just need to wait till it finish. And then once it's finished, here's the version ID you will need for create or updating the CloudFormation stack. So go to the search for CloudFormation as shown in the left corner, and click for. We will provide you a template for AWS CloudFormation template. You will just click create stack and upload the template that we provide to you. You just upload that one. And for in order to successfully create this stack, you will need a bunch of information. So for stack name, you can just enter whatever you want. And for the build bucket, you will just follow what the video did. And here is the key, just the name of the file you just upload, and you will need the version ID. For those two parameters, you can just enter what we shown here. And here you will need the path to the server executable here. Just copy that, but that's the absolute path. You will just cut that from part and leave it as a relative path. And if you want to add tags, do whatever you want, but you can just also leave it as empty. After doing that, you can just click next, and submit. It may take some time, but as it complete, here is once it complete, you will need those information in the outputs to update those variables in your game instance accordingly. So you just follow right here, and as like game live region, you just go to game live region and copy that alias ID. Pretty straightforward. Just go to output and put those information to the variable in your game instance accordingly. Client ID. So for every time you update or create a stack, making sure to also update those variables accordingly, or the game live may not work. Let's take a look at what being created by CloudFormation template. It has generated a dynamodb table to store friend requests and two indexes to speed up the data queries. Additionally, it has set up a GraphQL web API in AWS appsync with necessary schema and resolvers. Now, let's test it. I have created 3 accounts: test user 1, test user 2, and test user 3. First, we will send a friend request from test user 2 to test user 1. As expected, test user 1 received the request immediately, while test user 3 doesn't because they are involved. Next, we will delete the pending request from test user 2. Test user 1 received a notification and the request is removed from their pending friend list. Sending the request again from test user 2 to test user 1 produce the same result. Test user 3 remains unaffected. If we reject the request, test user 2 will get a notification that test user 1 has rejected them. When we send another request and accept it this time, test user 2 receives a notification of acceptance. And the request is moved from pending list to friend list. Finally, when we remove a friend, both test user 1 and test user 2 sees the friend removed from their list. And that's pretty much all for this tutorial.